Hello! I decided to create a short video to explain vector databases which are becoming increasingly popular in IT sector. This video is part of the vector databases series where we provide concise and to-the-point explanations of storage engine, indexing algorithms, built-in similarity metrics, optimizations, downsides and trade-offs, use cases, final thoughts for each database. If any of the terms or explanations are unclear, you can always look them up in the GPT or Google to better understand the fundamentals and principles of specific vector database. The goal of the video is to provide a short and concise covering only of the core concepts. Thank you and enjoy! And like and subscribe. I do need subscribes though. Thank you. Weaviate, a powerful open source vector database for AI search. It is designed for scalable and real-time similarity search. Unlike Pinecone, which is fully managed, or Qdrant, which is optimized for AI and search, Weaviate integrates structured data, keyword search, and vector search in one system. While Pinecone and Qdrant provide vector search with metadata or keyword filtering, it's not the same as Weaviate's true native hybrid search. It's widely used for Retrieval-Augmented Generation, Semantic search, and recommendation system with built-in hybrid search capabilities that make it ideal for LLM-based applications. Storage Engine. Weaviate uses a custom storage engine that blends in-memory, disk, and object storage for efficiency. It has the following features: LSM tree, log-structured merge tree, optimized for high-speed writes and fast retrievals, memory map indexing, frequently used data stays in RAM for low-latency queries, automatic tired storage, moves less used data to disk while keeping hot data in memory, object storage integration, stores large datasets cost-effectively. Persistent storage. Unlike pure in-memory databases, Weaviate stores vectors persistently. In conclusion, we can say its hybrid model makes it ideal for applications that require structured metadata search and NNN-based similarity search. Indexing algorithms. Weaviate primarily uses HNSW or Hierarchical Navigable Small World, but adds additional optimizations. Hierarchical Navigable Small World is a state-of-the-art algorithm for Approximate Nearest Neighbor or ANN search. It builds a multi-layered graph structure where each node connects to its closest neighbors, ensuring fast lookups. Next, BM25 Keyword Indexing, traditional text-based keyword search for hybrid retrieval. Hybrid search, vector and text, for example, supports both vector search and text search simultaneously. Reranking with transformers, uses reranking models like Cohere for more accurate search results. In conclusion, we can say the combination of HNSW and keyword search makes Weaviate ideal for multimodal search. For example, text, images, metadata, vectors, and others. Built-in similarity metrics. Weaviate offers built-in distance metrics to measure the similarity between vectors. For example, Cosine distance evaluates the cosine of the angle between two vectors, focusing on their direction regardless of magnitude. It's commonly used in natural language processing to assess document similarity. Dot product calculates the sum of the products of corresponding vector components, considering both magnitude and direction. It's useful in contexts like recommendation systems and ranking tasks. L2 squared or squared Euclidean distance measures the squared straight line distance between two vectors in multidimensional space, sensitive to the magnitude of the differences. Hamming distance counts the number of positions at which corresponding vector components differ, applicable to the binary vectors. Manhattan distance calculates the sum of the absolute differences between corresponding components of two vectors, measures distance along axes at the right angles. In conclusion, we can say in Weaviate the default distance metric is Cosine, but you can specify any of the above metrics in the vector index config field of your schema to suit your specific use cases. When configuring your Weaviate instance, it's essential to choose a distance metric that aligns with your data characteristics and objectives of your application to ensure optimal performance and relevant search results. Optimizations and benefits. Let's talk about a few optimizations and benefits that Weaviate provides. For example, hybrid search, vector and text search, mixes keyword-based search with vector embeddings, schema-based approach, allows storing structured metadata along with vectors, like a relational database. Real-time updates supports live inserts, updates and deletes, unlike some vector databases that require batch processing. Multi-tenant and multimodal support, working with multiple ML models like OpenAI, Cohere, Hugging Face, and custom embeddings. Integrated reranking models. Weaviate can rerank search results using transformers or LLM for more accuracy. Horizontal scalability distributes data across nodes for high availability, open source and self-hostable. Unlike Pinecone, you can run Weaviate locally or in the cloud. For conclusion, we can say the biggest strength of Weaviate is the hybrid search capabilities, combining structured metadata, text, and vector search in one system. Use cases where Weaviate shines. Weaviate is one of the best choices for LLM-powered applications, hybrid search, and AI-driven recommendations. Here I will lay out some of the examples. RAG, Retrieval-Augmented Generation, fetches relevant documents to improve LLM responses like OpenAI, LangChain, LlamaIndex, others. Semantic search, text and metadata, enhances traditional search engines with intent-based search. Very important. E-commerce and product recommendations, combines keywords and vector search for better product discovery. Multimodal search, text and images and videos, searches across multiple data types using embeddings. Enterprise knowledge bases, find relevant information for structured and unstructured data sources. In conclusion, we can say if you need hybrid search, structured and vector search, Weaviate is one of the best options available. Downsides and trade-offs. Despite its advantages, Weaviate has some or a few trade-offs. For example, more complex setup than Pinecone requires configuration schema definitions and metadata indexing. Memory intensive, like HNSW indexing, needs more RAM for large-scale indexing. Lack of full SQL support. Weaviate uses GraphQL-based queries, which may be unfamiliar to some developers. Higher latency for reranking. While hybrid search is powerful, ranking models adds extra latency. Storage cost for large datasets. Weaviate requires significant disk space for large vector databases. In conclusion, we can say, compared to Pinecone, that is fully managed, easier to use, Weaviate offers more control and customization, but at the cost of higher complexity and memory usage. Let's share some final thoughts. Weaviate is one of the best choices for hybrid search applications, especially if you need structured metadata, text search, vector search in one system. It's ideal for LLM-based track, semantic search, and multimodal retrieval. However, if you need a fully managed, low-maintenance solution, Pinecone is a better choice. If you prefer self-hosting a vector database with deep customization, Qdrant is also worth considering.